In this video, we show the equivalent of hyperbolic tangent in the form of the standard logistic exponential function, which is, we begin with the values of tangent wx, hyperbolic tangent, and the values of wr, data validation, list of items, that's 0.6 to 1.4. We can start with 0.6. And continue with the dataset of the hyperbolic tangent, so array formula. Hyperbolic tangent w times x. We continue with the standard logistic function, starting with the exponential function. But before we do that, we chart this. We can also chart this. Insert chart. And we use scatter chart. Use row 1 as header. And for the series, we show the trend line. The type, polynomial. The degree, 10. For the label, use the equation. For the legend, position at the left. So here's our trend line and the polynomial. We continue with the standard logistic function in the form of exponential function, starting with the exponential function. So array from exponent, that is w times x. So w times x. I'll show the equation. Edit chart, customize, series, show the trend line. The type, also polynomial. The degree, 10. And for the label, use the equation. Now we continue. There is a 2 minus 2 times wx. So minus 2 times wx. And there we continue, that is 1 plus. So this will be 1 plus. And after that we have 1 over. So this will be the quantity 1 over. And finally, there's minus 0.5. So minus 0.5 plus. Now we multiply this by 2. 2 times. Now they're the same. We change the value w to 0.8. We can do the same thing to the standard logistic function. Change this to hyperbolic tangent to 1. Change the value here to 1. We change this to 1.2. We can do the same thing. 1.2. Now they're the same. Change this to 1.4. We can also change this to 1.4. So this completes the use of the function exponent array formula to show the equivalent of hyperbolic tangent wx.